Okay guys, I hope everybody is doing well. We're going to look at writing and graphing exponential functions. And we've started looking at exponential functions. And these are functions where we have a variable in the exponent. So what we're going to look at is maybe we're given a table like this. And we're going to look at writing a function from the table. And then also being able to graph the function from there. So we have an XY table here. I've got coordinates essentially if I went all the way down the line. And we could graph this as it is, but what we really want to do is we want to write the function. What function is basically being represented here in this table. So our basic parent function form is going to be, if we can recall, it's y equals a and then bx. And that's why it's that exponential function right over there. We've got a variable in the exponent right there, the x. And we're trying to figure out, hey, we need values for the a and the b to really figure out what's being shown in this table right over here. So we can actually find the information in the table. So what we're going to start with first is we're going to start with the a. And remember that the a, if we go back to our notes on exponential functions, a is basically your starting value or your y-intercept. I'm just going to put starting right over here as a real fast review, or y-intercept, okay? So the way we can find that, if we had this on a graph, we could find the y-intercept straight from a graph. We have it on a table here. What we're going to look for is, remember, a y-intercept is always where the 0 is, right here, the 0 for x. So we're going to find, hey, that 0 for x, whatever the y is, where the 0 for x is going to represent the y-intercept. So what does that tell us? Well, that tells us that the y-intercept on this table, pretty basic, is 15. I'm going to wipe out some of this here so we can rewrite it down here at the bottom. So let's start filling in some of the information we have. We know y equals, so the a is that starting value. The a is going to be 15. That's our y-intercept, okay? Now we need the b value, okay? The b value is going to be like the rate of change or the amount we are multiplying by when we go from like here to there, here to there, here to there. Okay, well, let's make some observations. Let's look at how the y is changing from 15 to 45, from 45 to 135. Can we figure out what these numbers are being multiplied by? Sometimes it'll be pretty easy. I think this one is not too bad. And then sometimes you might have to do some division. If you look early on, it's always best to probably look early on in your table. That's usually you have some easier numbers to work with. 15 and 45, well, if you think about that, that's times 3, multiplying by 3. So 15 times 45 is 3. And then if we think about this pattern, 45, also times 3 would get you to 135. And basically, we could continue, but we're multiplying by 3. Well, 3 is going to be our b, our rate of change. So I'm going to just open this up, make a cleaner parentheses right over there, 3. And then we just leave the x just like that. So the function that is being represented here is 15 basically times 3 to the x power. That's the exponential function that's being shown in this table. And then if we needed to fill in values for the exponent, we could, and we could continue to work the table out if we needed to. But that's essentially what we've got to do here. If, like I said, if you are looking for your pattern in your table, and it's not clearly evident what you are multiplying by, what you're going to do is you're going to divide. So what you're going to do, I'll kind of wipe out some of this information here to mean to take away the x, but what you would do in that case is you would look at, basically, let's say you didn't have the factor to figure out what the pattern there was 15 times 3. All you do is multiply. If you take one of a second y value and you divide it by the one that comes before it, and you do 45 divided by 15. Of course, you're going to get 3, and that tells you. So you can always divide when it's not evident what's happening in your table. So our first one, y equals 15 times 3 to the x power. Let's try another one. All right, we got some negatives involved. A little bit of a different look on this one. Remember, we're looking at y equals a b to the x power. All right, cool. So let's look for the first thing. Usually the easiest thing to find is that y right over there. And I think we have it. We're just looking for the 0 right over there and the value for the y for the 0. That's our y-intercept. Well, it's going to be 24. So let's fill that in real quick. I'll do that in green. So we know we have a 24 for our our y value, our a. And the b is going to be our constant, like what are we multiplying by each time as we do this? Okay, well, a little tricky. Let's see if we can find this real fast. We kind of need to see, this is one of those that's not super evident. We started at 54, we got to 36, we're going to 24, we're going down. What's happening here? We're actually decreasing. All right, so let's do some division to figure this out. Well, if I take 24 right here and I divide by 36, that'll probably tell us what's happening. So I'm going to do that real quick. You would take 24, you would divide by 36. If you simplify this down really, because 12 goes into both of these real quick, this really makes 2/3. 12 goes into both of these. I'll write a little 12 up here so y'all understand how I did that. Divide by 12, divide by 12, just simplifying fraction. Essentially what's happening, and you could do this on your calculator too, you could simply just do 24 divided by 36. You're probably not going to get 2/3, you're probably going to get like 0.66 repeating, 0.667, something like that. But that's the same as 2/3. So what's happening each time? Well, we're multiplying by 2/3 or by 0.66 or 0.667, whatever that is. I'm going to put it in this 2/3. We usually want to put it in fraction form. So that means that over here in our constant, we're multiplying by 2/3, and then we've got x here. Now we could also talk about growth and decay right here. Remember our b value right over here kind of tells us growth or decay, what's happening. If the value is greater than 1, then we have growth. If it's in between 0 and 1, we're looking at decay. 2/3 is between 0 and 1, so this is going to be a graph. If we went ahead and graphed this thing out, it would show us a decay model essentially from the graph. Okay, so just remember that rule. All right, one more tricky one. It looks like we have all the information. We have the y equals a b to the x power right over here. Sounds good. And we can kind of start filling this out. The only thing is this. What if you are not given the y value straight off, or the y-intercept, I should say? There's no 0 on here, okay? There's no 0 up here in this start. It starts with 1. We go through 4, but there's no 0. Okay, we can still figure it out. What we want to figure out first is, let's go after the b value, okay? So the b value right over here is what's happening each time. 1 to 5, 5 to 25, 25 to 125. Oh, well, this is kind of fairly evident. We could divide if you want. You can do 25, say, divided by 5 if you wanted to get that. But you're going to get 5. And to some of you guys, that was probably clearly evident. So our b value, as I make a little space here, is going to be 5. So I can go y equals a, and we're going to have 5 to the x power. Okay, cool. So we know each time we're multiplying by 5, or if we divide by 5 here, everywhere if we divide by 5, we divide by 5 there. If I divide by 5 here, if I divide by 5 here, I'm going to get the value for the previous number. So let's get the y-intercept. We know the y-intercept is going to be, make a little line, 0. So couldn't we just take the 1 right here, the 1, and we could divide it by 5, okay? Well, if you do 1 divided by 5, you can do the whole thing. You can do 1.0. You're going to get 0.20, okay? You can do it on the calculator. Or essentially just 1/5. You can leave it in fraction form. So that's going to mean the y-intercept actually is going to be, I'll write this out in purple, y equals 1/5 is going to be where the y-intercept is, and then we're going to have our b value of 5 with the x right over there, okay? All right, so what if you need to graph real quick? So we get the table. How do we go and how do we graph this? Okay, I'll try to go through this kind of quick. And this is a fairly basic one. Really only, we don't even have like kind of a y value in here. So what you want to do if you're given a function, so this time we're actually given the function, we want to graph it right over here. We want to start with a table. Okay, so I'm just going to jot down a real quick table here, bring it down. All right, and we're going to write in just some random values for the table. It's always good to put a couple negatives and some positives in here. So let's start. Let's go with -2, nothing too high. So I'm going to do -2, -1, give us a little space. Let's do 0, let's do 1, and let's do 2. I'll finish it out at 3. Okay. All right, these are all going to be your x values, and these will be basically your y as we put this in. Well, all we're really doing then is inputting the -2 there, or our x values for our exponent, okay? So let's try that real quick. Let's start with the -2, okay? Now let's remember some exponent rules here, okay? I'm basically taking 2 to the -2 power. When you take 2 to the -2 power, essentially you're creating a fraction here, okay? -2 as an exponent, or 2 to the -2 power, what you really do, and we did some video notes on this a little while ago, is this really turns into 1 over, we make it positive, 2 to the second power. 1 over 2 to the second power. Well, 1 over 2 to the second power, 2 to the second power is 4, right? So this is basically 1 over 4. So what we're going to get here is 1/4, okay? So I'll do another one of those just in case you didn't catch all that, because we'll have another one to throw in there. On the next one, we do a 2 to the -1 power, -1 power. Okay, well, what do? We turn this kind of into a fraction, not kind of, we do. We make it 1 over 2 to the first power. 2 to the first power is just 2 right here. 2 to the first power is just 2. So this basically turns into 1 over 2, or 1/2. So I kind of keep this thing going, and now we've got 1/2 in there, if this will work. There we go. All right, this is going to get easier now. The negative ones are a little challenging. The positive ones I'm not super worried about for you guys, okay? 0. We place a 0. Anytime you put 0 in an exponent, it doesn't matter what your value is here for your exponent, your constant value, I should say. It's going to be 1. Your value is 1 anytime for 0, okay? All right, let's keep it going. So if I put a 1 in, that's the same as 2 to the first power. 2 to the first power is 2. And if I put a 2 in, 2 to the second power is 2 squared. That's 4. And 2 to the third power, that's the same as 2 times 2 times 2. 2 times 2 is 4. Times 2 is 8. Cool. Now this gives us something we can graph. We've got x and we've got y. So my first one here, I've got a -2 and then 1/4. So I'm going to graph it on the grid right over here, and you can follow along. So -2 means I'm going over 2 spaces, 1, 2 there. And then just up 1/4. Check this out. 1/4 is pretty low. It's down here, kind of where I put that little dot. That's going to be right about where the 1/4 is, -2 and 1/4, okay? I got that one. Now we're going to put one at -1.5. Okay, well that's -1 here. A half, just a little higher, but not a whole lot. Put it like right there. All right, so remember with the negatives, we're going to deal with some really, really low values and some numbers close to the 0 axis here, okay? Or on our x-axis, 0 on our x-axis. 0, we got our y-intercept. 0 is going to be at 1, so that's going to be right over there. Got it. 2 is going to be at, 1 is going to be at 2, I'm sorry, so 1 and 2 would go right there. 2 and 4 would be 2, 1, 2, 3, 4 right there. And the last one we have is 3 and 8. 3, 4, 5, 6, 7, 8 should look something like that. And here's where you'll get kind of that exponential function look that we are kind of used to, that kind of curve that goes up and kind of takes off that way, okay? So that's how we can graph it, creating a table and taking it from there. One more if you get one like this, and you've got a little bit longer of an exponential function here. Again, I've got y equals -2, and then I've got 2 to the x power. Again, I should say you're going to make the table. We're going to do your x, you're going to do your y. And let's put in some numbers here. Let's do the same thing. We'll do -2. We'll do -1. I'll bring it down just a little bit. Let's go 0, 1, 2, 3. Nothing too high, nothing too complicated. All right, let's input these values for the exponent here. Okay, got it right over there. All right, let's do it. So we're going to do a -2. That means it's going to look like this. I'm going to have -2 times 2 to the -2 power. Let's remember these exponent rules. Let's deal with this in the exponent first, okay? That's going to be 1 over 2 to the second power, okay? So 2 to the second power is 4, so that's basically going to be 1/4. So this will really be 1/4. And we're going to take 1/4, remember we've got to plug it back into this. So I've got a -2 times a 1/4. Well, you could take your calculator out and plug that in, -2 times 1/4. But if you do negative 2 times 1/4, you are going to end up with negative 2 times 1/4. You're going to end up with negative 1/2. So it'll come into negative 1/2. You can plug that into the calculator and look. But let's continue on from here. Remember, the negatives are the ones that are a little bit longer, and then it kind of takes off from there. So if we put a negative 1 in now, same thing. I got negative 2 to the negative 1 power, just like that. Okay. So do the exponent. That's the same as 1 over 2 to the first power, which is the same as 1 over 2, or 1/2. So then we're basically taking negative 2 and multiplying it by 1/2 right over here. And you should get negative 1. So we get negative 1 there. And then we can kind of take off from here a little bit faster and throw the graph in. Remember 0. What do we get when we put a 0 in? Go 0 in, it's going to be 1. Anytime you put a 0 in, you're going to get 1. I'm sorry, hold off. It's going to be negative 1. It's going to be y equals negative 2. The 1 will be in there, I should say. So it's negative 2 times 1. I got ahead of myself there. So when we have negative 2 times 1, you're going to get negative 2 there. So you're going to get 0. You would put in negative 2. And then for your 1, going to plug a 1 in here. Negative 2 times 2 to the first power. Well, 2 to the first power right here. If you do this section, that's just going to be 2. Negative 2 times 2 is negative 4. And we kind of keep this going from here. 2 more to get. I've got negative 2 in, negative 2 to the 2 squared power. 2 squared is 4. So you got negative 2 times 4. That's going to get you negative 8. And then if you follow the pattern, you'll see how it's going to go. We put the 3 in. We'll get 8. You're going to get negative 16. Right over there, and that gives us the information we need to graph it in. Now this will have a little bit of a different look to it because of the negatives we have at the front. So I've got one with negative 2, my first coordinate right over here, negative 2 and negative 1/2. Well, negative 2 is like here, negative 1/2, got it, just right there. Next one, negative 1 and negative 1. So I'm here at negative 1 and negative 1, right down over here. And I haven't really numbered these off, but hopefully are kind of catching that. 0 and negative 2. 0 and negative 2 should kind of take you to right there. That's our 0 and then down 2. 1 and negative 4 would be over 1 and down to negative 4, which is right there. I've got 2 and negative 8, and that's going to get me right there. And the last one would be 3 and negative 16. So that's 8, 9, 10, 11, 12, 14. Ooh, that's going to take us all the way to the bottom on the third one. And just like that kind of last one we did, we're going to get the same kind of look of that exponential function, just like that, okay? So, just making sure you plug in for your exponents. Remember, your negative ones kind of have a fraction look. Any exponent to 0 is the same as 1, and then you can plug it in. And great job with the exponential functions.